Okay, we shall start. Could you please confirm once that I am audible as well as visible? Just confirm once that I am audible, visible, as well as you can see these slides. Okay. Okay. Very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department from IIT Kharagpur, and I will be taking your live interactive session for the course Problem Solving Through Programming in C. This course is taught by Professor Anupam Basu from IIT Kharagpur. And what we'll be doing, I'll be posting some of the questions, objective questions based on the previous week's content in front of you all. And what you have to do, you just have to answer the questions using the chat box. Okay. So we shall proceed. Okay. Yes. The very first question for the present session is this one. Interpolation is a process for extracting feasible data from the given set of data, or is it finding a value between 2 points on a line or a curve, or removing unnecessary points from a curve, or all of the above? Do try to answer this particular question. What is the meaning of interpolation? That is the question wants to know from you. Okay, do try to answer. Yes, do try to answer. Even though if you don't know, try to answer. Okay, have a guess. What is interpolation? Okay, one person is saying extracting feasible data set from a given set of data. Okay, what about the others? Do try to answer. What do you mean by interpolation? Please do answer. Check out on the options. Try to answer. Yes. B. Okay. Finding a value between 2 points on a line or a curve. See, this present session is based on mathematics, purely based on mathematics. So keep a copy, pen and paper handy with you. Okay. Keep a pen and paper as well as calculator handy with you. I'll let you walk through some examples also. Okay. Yes. Do try to answer what has happened. It is not that much difficult. Interpolation. Interpolation is a process for extracting feasible data from a set of given data from a given set of data, or finding a value between 2 points on a line or a curve, or removing unnecessary points from a curve. Okay, B, then A, then all of the above. Okay, do try to answer. Yes, what has happened? Why such few responses? Haven't you read the previous week's content or what? Okay, A, then B. Okay, good. Only one person is correct till yet. It is indeed B, finding a value between 2 points on a line or a curve. Okay. I am Again requesting you keep a pen and paper calculator handy with you. This is purely mathematical. As I am solving, you should also try to solve on the copy and pen using your notebook and pen. Okay. Keep a calculator handy with you. Okay. Yes, try to understand. If you are not thorough, then please do understand. Correct answer would be B, finding a value between 2 points on a line or a curve. Interpolation is a method which is used to estimate values within a known range of data points. Specifically, it is used to find the intermediate values. Options A and C are just describing it in the different process. Okay. And the correct option would be B only. Okay. This one. Finding a value between 2 points on a line or a curve. Very basic mathematics. For example, just take it a example. Use your pen and paper. Okay. Jot it down as well as try to solve with me. For example, you have to estimate temperature between two times. This is a example of where you will apply interpolation and how you will apply interpolation. Okay. Suppose you recorded the temperature at two times in the morning at 8 a.m. Suppose the temperature is 15 degrees C and 10 a.m. At 10 a.m. it was 19 degrees C. Okay. So now if you want to estimate or you want to know the temperature at 9 a.m. using linear interpolation. Interpolation can be of linear of various types. It can be linear, it can be quadratic, it can be cubic. If you are going through polynomial functions, okay, you generally the relationship between the dependent and independent variable is assumed to be linear. Okay, so thereby the role of interpolation comes into play. But using the when you are using the advanced methods for estimating values like finite element analysis, there you can even go for higher degree polynomials as well as different types of functions, maybe cubic, maybe exponential. Whatever is the relation between the dependent and independent variables, that you have to keep in mind, and that is how you will choose the function. Okay, so here I am estimating the temperature at 9 a.m. Okay, using the linear interpolation. Okay, how will I do? First of all, I am having two different axes. Y is the temperature, x is the time. Okay, this I'll keep it in mind. Then two different data points are there, x and y. Okay, 2 points which would be there at 8 a.m. The temperature is 15. At 10 a.m. the temperature is 19. Hence two different points I am getting, 8 and 15 and 10 and 19. Okay. Now you see, you want to estimate the temperature at x equal to 9. Okay. So apply this particular formula. This is the formula for linear interpolation. Okay. This particular one is the formula for linear interpolation. You always have to keep it in mind. Okay. Or else you can fit a line between the 2 points. That from there only it has come. Okay. Y equal to y1 plus x minus x1, y2 minus y1 over x2 minus x1. This is this particular term. Okay. Y2 minus y1 over x2 minus x1 is nothing but the slope. This particular term is the slope. So what is the equation of a line which is passing through a point and having a slope y equal to mx plus y equal to y1 plus mx minus x1. Okay, this is the equation. So in place of m, I have substituted y2 minus y1 over x2 minus x1. Okay. Otherwise, you can also try to fit the line between these 2 points using the standard line equation y equal to mx plus c. You will get the same result. Okay. Now you substitute all the values. Temperature at 9, y I have replaced with temperature, and x I have kept as time. Okay. Y equal to y1, which is 15. Okay. This particular first point. then y2 minus y1 over x2 minus x1, 19 minus 15 over 10 minus 8, and x minus x1. X directly I have substituted as 9 and x1 is 8. When you will solve, you will get the temperature as 17. This is an example of linear interpolation. Okay. Yes. Any doubts in this particular question? What is linear interpolation? What is interpolation? And what is this function and how you will do it? Any doubts anywhere? Or is it clear? If it is clear, then we'll move forward. Any doubts in any slide? What has happened? Do write down it is clear, not clear. Thereby I can move forward. It is clear? Okay, good. Sir, what about option A and C? Okay, good. Extracting feasible data set from a given set of data. This is data manipulation. This comes under data manipulation. Extracting feasible data set from a given set of data where you remove the outliers. Okay. This is another different process of generating the adequate data for training the model. Okay. And removing unnecessary points from a curve. This is done in regression analysis. Okay. When you try to fit in a polynomial function, exponential function, or any other function, okay, then this particular process is carried out. So the question specifically is asking about interpolation. Interpolation directly is the finding a value between 2 points on a line or a curve. Okay, interpolate. It means the initial data set points x1 y1 and x2 y2 are known, and you are trying to fit a different point in between those, that is x3 and y3. Okay, so this won't be correct. This is another thing, data pre-processing. This is done in regression analysis. This won't be correct. Only correct option would be B only. Okay, Arunima. Okay, let's move forward. Try to solve. Given two data points a comma fa and b comma f of b, then the linear Lagrange polynomial f of x that passes through these 2 points are given as. You have been already taught the standard notation of Lagrange polynomial. Using that, try to answer this particular question. Okay. Yes. Why only two options? Two people only have answered D. What has happened? Try to be more responsive. A lot of students have joined. At least try to answer. Maybe you are incorrect in the very first attempt, but still you will have some amount of confidence. Okay. What is the nature of your examination? Is it objective or subjective? Have you checked? Objective. Okay. Very good. Then be prepared for these type of questions. Okay. All the PDFs already I have supplied for you. This is the third last session. Okay. Week 12 will be there, as well as I'll be taking a summary session, most probably on 13th. Next class would be on 12th. After that, summary session I'll take on 13th. Do join that. Okay. As well as revise all the PDFs before the examination. Okay. So that you can easily answer the questions. Okay. Yes. Given two data points, a comma f of a and b comma f of b. Okay. The Lagrange polynomial f of x that passes through these 2 points is definitely given as d. Yes, you are correct. No problem. In this particular question, only three people have answered and a lot of students have joined. It is d only. F of x equal to x minus b a minus over a minus b f of a plus x minus a over b minus a f of b. How does it come? Just see. Okay. First of all, understand what is a Lagrange interpolation or Lagrange polynomial. It is first of all, you understand the interpolation. It is a method for estimating function values between the data points. I already told you. Then given a set of data points x naught y naught plus x1 y1, similarly x and yn, the interpolation helps us to construct a function which is the px, okay, or polynomial of x that exactly passes through these all the points. Okay. One of the most common forms of interpolation is Lagrange interpolation. Okay, which is what? It's a polynomial function to fit the given data points. Okay. What is Lagrange interpolation? It's a method of constructing an interpolating polynomial that passes through a given set of points. Already told you. Especially useful when the function itself is unknown, but a few values of it are available. Okay. For n plus 1 data points, Lagrange polynomial is given by this particular expression px equal to summation I equal to 0 to n lix f of xi. Okay. This particular expression you have to just keep a note of it. Okay. If you are having pen and paper, already I have told you, please note it down. Okay. If it had been an offline class, then I would have got a better idea whether you are able to understand or not. But since it is an online class, help yourself, take a pen and paper, okay, and note it down. Px is the Lagrange interpolation polynomial and it is given by the expression summation I equal to 0 to n lix f of xi. Okay, where lix are the Lagrange basis polynomials. Okay, Lagrange basis polynomials. How is it defined? Lix equal to product. This is product of j equal to 0 to n x minus xj xi minus xj, where j should not be equal to I. This particular condition, j is not equal to I, will give you the exact number of terms which would be there in the product of the terms x minus xj over xi minus xj. Okay. These many number of terms, this particular condition is the limiting condition. Which is the limiting condition? J is not equal to I. This will restrict the number of terms in the whole product. Okay. Each lix uh, is constructed such that lixi equal to 1. Okay. As well as another condition, lixj is always equal to 0. Two particular limiting conditions are there. Lixi equal to 1 as well as Lixj is equal to 0. for j not equal to I. These two are the particular limiting conditions that you have to keep in mind. This ensures that when substituted into the formula, the px takes the exact values of f of x at the given points. Okay? Yes. Take a pen and paper, write down these expressions. Both the expressions are very, very important. They would be used in solving the questions which will come after this. Okay? Now you see these expressions, two expressions only I am asking you to remember. Px is summation I equal to 0 to n Lix f of xi Lix equal to pi product j equal to 0 to n x minus xj over xi minus xj. Only two expressions. Okay. Now you have been given two particular points. First point is a comma f of a. Second point is b comma f of b. So you already know that your Lagrange polynomial or the Lagrange equation that has to pass through these particular points a comma f of a, b comma f of b. Now I will construct the polynomial using this particular expression only. Okay, 2 points have been given to me. So what I will write down, px equal to L1x and f of a, because the first point is a and the value of function is f of a, plus L2x f of b. Now I need to know what two terms I need to know, which is L1x and L2x. Okay. So from this expression, you can see x1 you can take as a and x2 you can take as b. So L1x will be x minus x2 because j is not equal to I. I cannot write down x1 here because since I'm denoting the expression of L1x, L1x, I is 1 here. So there j cannot be equal to I. So that is why I have written x minus x2 over x1 minus x2. Okay. Similarly, the expression for L2x will be x minus x1 over x2 minus x1. Here, one particular division symbol is not there. Yeah, this would be there. Okay. So what is the final expression? Just a second. I'll make it more correct. Yeah. 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 So L1x is x minus x2 over x1 minus x2. When I am writing down L2x, the term L2x. So when I am writing L2x, I is 1, I is 2 here. So 2, I cannot write it down as xj. J cannot be equal to 2. Hence j is equal to 1 only. So you write down x minus x1 over x2 minus x1. Whatever term xj you are writing down, you just have to make the same xj in the denominator also. Okay, so substituting the values of x1 and x2, I will get L1x as x minus b over a minus b. No another terms would be there. Okay, because 2 points only have been given here, so I'll go through them only. Okay, then L2x will be equal to x minus a over b minus a. Okay, these basis polynomials have to satisfy the condition L1a or L1a has to be equal to 1. When you will substitute a at in L1x, then it will be equal to 1 only, as well as L1b will be equal to 0. Okay, L2a will be equal to 0 and L2b equal to 1. You can easily see this. Okay. Final Lagrangian polynomial or Lagrange interpolation formula or the polynomial which will come will be Px, which is L1x f of a plus L2x f of b. Substitute L1x and L2x, you will get this particular expression. Okay. which is x minus b over a minus b f of a plus x minus a over b minus a f of b. Okay. This is the unique linear polynomial which is passing through 2 points. Okay. This is the thing. What is the geometric interpretation? Lagrange polynomial or Lagrange interpolation polynomial for 2 points is simply a equation of straight line which is passing through both the points. Okay. It's a first degree polynomial which can be uniquely determined by the 2 points. Interpolation formula is nothing but the equation of the line in the slope intercept form. Okay. So this is coming like this. Px is f of a plus f of b minus a f of a over b minus a x minus a. Point slope form of the equation of the line. Okay. Properties are given here. Exactness, the polynomial exactly passes through all the points. You can easily say in the previous expression. Okay. Uniqueness, for n plus 1 distinct points, there exists a unique polynomial of degree n which should pass. Okay. Uh, at most n and interpolate them, and scalability can be extended to higher degrees or more number of points. Okay, this is the entire thing regarding the Lagrange polynomial. Okay, comparison with other interpolation methods. What are the different other interpolation method? Newton-Raphson interpolation is there, or Newton's interpolation is there. Spline interpolation is there, or linear interpolation is there, which is the same thing only, Lagrange interpolation. Okay. Newton's interpolation uses divided differences, and it is more efficient when you are adding two different points, while spline interpolation uses piecewise polynomials of higher orders for smoother curves. Okay, these two you will see if you will take the course of numerical methods. Okay, then practical examples or practical applications of linear interpolation include temperature estimation, then curve fitting in the engineering structural analysis, as well as in financing for stock price estimation, as well as in computer graphics for rendering. Okay, this particular is the practical applications of the linear interpolation. Okay. Yeah, it's a powerful and elegant method to construct polynomials passing through the given points. Okay, definitely it is true. Okay, this is the end. Okay, here if you don't want this much explanation, then this is the explanation in short. Okay, just try to remember f of x is I equal to 0 to n minus 1 lix f of xi, and lix is pi or product j equal to 0 to n minus 1 x minus xj over xi minus xj. And from there, easily you can find out what is the Lagrange interpolation formula. Okay. Any doubts, anybody? Is it clear? If it is clear, write down we are clear. If it is not clear, then ask here itself. Okay. Okay, no doubt. Okay, good. If at any point of time any student is having any doubt, please clear itself here itself. Okay. Don't leave it pending. Okay. Yes. This is the explanation, whatever I have spoken till yet. Okay. If you are not clear anywhere, then try to go through the explanation. I have gone through the expression and how we are achieving the expression. Everything we have written here. Okay. I'm moving forward to the next question. Okay. To solve a differential equation using the Renz-Kutta method, the necessary inputs from the user to the algorithm is the differential equation dy by dx in the form x and y, the step size based on which the iterations are executed, or the initial value of y, or all of the above. Okay, do try to answer. D, good. Okay, D. Good. Okay, D. Good. Yes, indeed, you all are correct. The correct option would be D only, the differential equation dy by dx in the form x and y. The step size based on which the iterations are executed, the initial value of y, all of these above are correct. To solve the differential equation using the Runge-Kutta method, you require all of these inputs. Okay. Yes. Try to see what is the Runge-Kutta method. It's a numerical technique to solve the ODEs, ordinary differential equation of the especially initial value problems. Initial value problems are those problems in which you would be given a particular uh, value of f of x at any particular suitable x0 point. Okay, means one value would be given which is the initial value of the expression of the y. Okay. So Runge-Kutta method is a numerical technique which is used to solve the ODEs or ordinary differential equations, especially the initial value problems of the form dy by dx equal to f of x comma y, where y x0 equal to y naught. This particular thing which you are seeing here, this is known as the initial value. Okay. Yes. It gives the approximate values of y at points x1 equal to x naught plus h, x2 equal to x naught plus 2h, plus and so on. This particular technique is applied when the exact solution we are not able to achieve, okay, by solving the differential equation. Okay. Basic idea is starting from a point x0 comma y0 or x naught comma y naught, then using smart averaging of these slopes to estimate the next value at y1 equal to y of x naught plus h, and then repeating this particular step at x1, x2, x3, and so on. Okay. Fourth order Runge-Kutta method. This is the fourth order Runge-Kutta method. How exactly we are performing it? This has been mentioned in this slide. Okay, take a pen and paper, write down these particular notations, very helpful for you to solve a particular differential equation using this particular method. Suppose you have been given a value, given a differential equation dy by dx equal to f of x comma y. Then the initial condition is y x naught equal to y naught. Okay, and a particular step size that would be mentioned in the question. Otherwise, you can calculate. Step size would be mentioned in the question. Otherwise, you can calculate it. Okay, using the expression h equal to b minus a over n, where n will be the number of values and b and a are the bounds. Okay, so that would be mentioned in the question. Okay, then using the Runge-Kutta method or RK4 method, you will calculate four different coefficients, which is K1. K1 is h multiplied by f of xn comma yn. Then K2 is h multiplied by f of xn plus h by 2 yn plus k1 by 2. Then K3 is h into f of xn plus h by 2 yn plus k2 by 2. Then K4 is h into f of xn plus h yn plus k3. Okay, these all the four different coefficients you have to find out in the Runge-Kutta method. Okay, try to see here these four different coefficients. When you will be finding out, everything has been given to you, y naught has been given to you, x naught has been given to you, h has been given to you. You just have to find out these particular four coefficients. After that, the next value which we will find out is yn plus 1, or the expression yn at the value of x where you were required to find out its value. That will be yn, which is the initial value, plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. And xn plus 1 is xn plus h. This is the thing. Final expression for yn is given here. Okay. This is the Runge-Kutta method. Okay, for calculating the solving the ordinary differential equation of the form dy by dx equal to f of xy. Okay. Four slopes. K1 is the slope at the beginning of the interval. K2 is the slope at the midpoint using the K1. K3 is another midpoint slope but using improved K2. And K4 is the end slope. Okay, slope at the end using K3. Then averaging gives the much better approximation than the simpler methods. Other simpler methods are Euler method. Example is Euler method. Okay. Step by step, I am solving one particular example in front of you. Okay. Have your pen and paper ready and write down the example. Okay. We'll just try to solve here. dy by dx has been given as x plus y. Okay. y0 is equal to 1. Okay. Means x naught is 0 and y naught is 1, and h has been given as 0.1. Okay, these three particular values will be given to you. Now you have to solve this particular differential equation. So you write down the expression as k1. K1 value you already know, which is h into f of x naught comma y naught. So h has been given as 0.1 multiplied by f of x is x plus y, and x naught is 0 and y naught is 1. So 0.1 multiplied by 0 plus 1 will be equal to 0.1. So k1 directly I have calculated here. Okay, k1 is known to me. Now k2 is what? 0.1 h into f of x naught plus h by 2 plus y naught plus k1 by 2. Okay, this particular expression we will just try to evaluate. Then k2 will be equal to 0.1 into 0.05 plus 1.05. That will be equal to 0.11. Similarly, try to calculate the expression k3. Then try to calculate the expression k4. Then y1 will be equal to y0 plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. That will be equal to 1 plus 1 by 6, 0.1 plus 2 into 0.11 plus 2 into 0.1105 plus 0.12105. And the approximate value of the expression which you will get as 1.11034. So at x equal to 0.1, the value of y is 1.11034. Okay. Just you have to keep in mind the expression. Okay. Keep in mind the expression, the value of the constants k1, k2, k3, k4, as well as what is the final expression yn plus 1. yn plus 1 is yn plus 1 by 6, k1 plus 2, k2 plus 2, k3 plus k4. K1 is h into f of xn comma yn. Then k2 is h into f of xn plus h by 2 yn plus k1 by 2. Then k3 is h into f of xn plus h by 2 comma yn plus k2 by 2. And k4 is f h into f of xn plus h. Okay, h by 2 plus h by 2 will be h. So h into f of xn plus h yn plus k3. Okay, these are for k1, k2, k3 and k4 and the final expression. Why I am repeating so many number of times? So that here itself you are able to memorize it. Okay, there is no any other short trick or anything like that which I can tell you. Just have to memorize the expression and then you have to solve it in the examination. There is no other method in which I can directly transmit this whole formula, all the formulas inside your brain. Only thing is practice as well as revising and repeating the things. Okay. What are the advantages which I get in this particular Range-Kutta method? Very accurate, even at relatively large step sizes. It is accurate. It doesn't require the derivative f of x comma y. It's widely used in engineering, physics, biology. In every place it is used because it's an empirical method. You are easily able to solve any differential equation using it. Okay, as well as you would be able to write an algorithm using this particular method. Okay, the Range-Kutta method, especially RK4, gives you a smart way by solving step by step from a known starting point to approximate solution of the differential equation. Balances the accuracy and efficiency. It's a go-to method in many scientific and engineering fields. Okay, this is the expression. D would be correct. As you know that Range-Kutta method is a numerical technique for solving ODE of the form dy by dx equal to f of xy. Okay, differential equation should be known to you, step size should be known to you, and initial value y naught at x naught should be known to you. Hence, all of the above would be correct option. Okay, and whatever I spoke till here, that has been summarized in this particular slide. Okay, are you clear? Any doubts, anybody? If you are having any doubt at any point of time, please unmute yourself, ask me. Okay, I'll explain you once again. Or if you are having any curiosity, then still you can ask. Okay, be clear. Don't leave everything for the examination because it is very near. Okay, yes. Now let's move forward. Okay, all the questions which would be there in the present session based on this Lagrange polynomial and Range-Kutta method only. That is why I told you that please write down the expressions. Okay, we'll be solving a lot of questions today. Here, what is the question? A Lagrange polynomial passes through three data points as given below. X is 10, 15 and 20. F of x is 3, 5.2, 6.8. The polynomial is determined as f of x equal to summation li x f of xi. Okay, so fx is L naught x multiplied by 3 plus L1x multiplied by 5.2 plus L2x multiplied by 6.8. You just have to calculate the value of L1x at x equal to 18. Okay, yes, Cyan has answered it 0.64. Okay, good. Any other people? Please do try to answer. Take 2-3 minutes time. Try to solve it. Just have to know the expression and create the expression. Then you just have to solve it. Okay. Okay, sure is getting B. Good. Cyan is getting A, Shore is getting B, and nobody else is getting anything. Okay, I can understand. But just go through the entire solution. Okay, after the class is over, at least practice it once again. These entire 10 questions are very, very important. Okay, this whole thing has been taught in week number 11. Okay, yeah. The correct value would be 0.64 that you will only get if you are able to solve. Okay, I already told you, just have to remember two particular expression when it comes to Lagrange polynomial interpolation, which is px equal to summation I equal to 0 to n lix f of xi, and another expression is lix equal to product x j equal to 0 to n x minus xj over xi minus xj. These only two different terms you have to remember. Okay. Now, from the table, very easily you would be able to see that x0, okay, x0 is 10, x1 is 15, and x2 is 20. Okay, xi's. Okay, three different x's there. Okay, these are xi's. This is 10, 15, and 20. Only this particular thing we just have to see from the table in order to calculate the value of the expression L1x. Okay, at x equal to 15, at x equal to 18. Okay, so xi is I have seen. Okay, now I will expand this particular expression. Try to see in the right hand side. Okay, L1x is equal to product xi x minus xj over xi minus xj. So if I am writing L1x, okay, so j cannot be equal to 1. Okay, so I'll move systematically. Okay, first of all, I'll proceed with x0. Okay, so I'll write down product. Okay, x minus x0 over x1 minus x0. This would be my first term. Then three different points are there. I cannot proceed with x1. Xj cannot be equal to 1. Xj cannot be equal to x1 because j cannot be equal to I. So I'll move down towards the next term, which will be x minus x2 over x1 minus x2. So only these two different terms would be there in the expression L1x, where I am taking in consideration three different points x0, x1, and x2. Okay, this is the thing x0, x1, x2. Okay, three different points I am taking, and I have expanded the expression of L1x. Okay, now when the expression I have made, half of my job is over. Okay, just I have to substitute x0 as 10. Okay, I have to substitute x0 as 10, x1 is 15, and x2 as 20. So L1x will be equal to x minus 10 over 15 minus 10 product x minus 20 over 15 minus 20. So L1x will be x minus 10 over 5 multiplied by x minus 20 over minus 5. So I can write it down L1x as minus of x minus 10 into x minus 20 over 5 5 is 25. So I wrote it down 25. Now just I have to substitute the value as 18. Okay, so L1 18 is negative of 18 minus 10, 18 multiplied by 18 minus 20 over 25, that is 8 into minus 2, negative is outside the bracket over 25. Minus minus is plus, so final expression is 16 by 25, which when you will evaluate value, which you will get it is 0.64. Okay, 16 by 25 is 0.64. Okay, there is no doubt in that. Yes, directly it is coming as 0.64. Okay, yeah, is it clear? Those of you who are not able to answer this particular question, is it clear to you? Any doubt is there, then feel free to ask. Okay, clear? Very good. If it is clear, then it is fine. Otherwise, please do ask me. Okay. Very important questions you will be able to solve only when you will know the formula, when you will know the concept. Else, you won't be able to guess in it. Okay. There is no guessing. The answer is very crisp and to the point. Okay. Yes. Moving forward, the value of the integral 0 to 3.2 x e power x dx by using one segment trapezoidal rule. This you have to find that down using the expression of trapezoidal rule, but it is with a twist. It is saying only use one segment. Okay. Try to calculate. Okay. Sure has answered it as B. Okay. Take few minutes time. Try to answer. Cyan has also answered it B. Good. Two students have answered. Very nice. Okay. Arunima has also answered it B. Good. Very nice. It is indeed B 125.6. When you will solve, you will get it. Okay. First of all, understand what is trapezoidal rule formula. Okay. For using when you are using one segment only. Okay. When you are using one segment only, the trapezoidal formula reduces to definite integral a to b f of x dx is given by the expression b minus a by 2 f of a plus f of b. Now a is here 0, then b here is 3.2, f of x is x into e power x. Okay. Evaluating the f of a and f of b for x equal to 0, it will be 0 into e raised to power 0, which will be equal to 0. For x equal to x equal to 3.2, okay, it will be f of 3.2. F of 3.2 is 3.2 multiplied by e raised to power 3.2. That will be equal to how much? E raised to power 3.2 is 24.5325. Okay. F of 3.2 is 3.2 into 24.5325, which is 78.504. Okay. Now you calculate 0 indefinite integral 0 to 3.2 x raised to power x into e raised to power x dx will be given by this expression b minus a 3.20 minus 0 divided by 2. Okay. F of a plus f of b in bracket. So 3.2 divided by 2, 0 plus 78.504. Okay. That would be 1.6 times of 78.504, that is 125.6. Okay. So this is the correct option is 125.6. Okay. What is trapezoidal rule? Trapezoidal rule is a numerical method. It is also a numerical method, just like the Lenz-Kutta method. Okay. But the function is different. The trapezoidal rule is a numerical method which is used to evaluate the definite integral of the function of the type definite integral a to b f of x dx. It works by dividing the area under the curve into trapezoids rather than rectangles like the like in the Riemann sum or the Euler method. Okay, so that is the thing. It works by dividing the area under the curve into different trapezoids rather than rectangles. Okay, like in there, like it is there in the Riemann sum or the Euler method. Each trapezoid is estimating the area under the curve for a small subinterval. Why is it known as trapezoidal rule? Because area under the curve between 2 points xi and xi plus 1 is approximated by the area of the trapezoid, which is half of f of xi plus f of xi plus 1 multiplied by h. That is half of sum of two parallel sides multiplied by the distance between them. This is the area under the curve trapezoid. Okay, where f of xi and f of xi plus 1 are the functions at the endpoints. H is the subinterval xi plus 1 minus xi. Okay. Trapezoidal rule formula says if you are using only one interval, then you have to go with the formula definite integral a to b f of x dx is b minus a by 2 f of a plus f of b. Then trapezoidal rule for multiple intervals or the composite form is definite integral a to b f of x dx is given by the formula by the expression h by 2 multiplied by f of x0 plus 2 times f of x1 plus 2 times f of x2 plus and so on up to 2 times f of xn minus 1 plus f of xn. Okay. The only term which are getting added is this particular one only, middle terms. 2 times f of x1 plus 2 times f of x2. These only are the terms which are getting added. Okay. Rest everything is same. These terms only are getting added up to 2 times f of xn minus 1. Okay. So now you see definite integral a to b f of x dx is h by 2 f of a, okay, plus 2 times summation I equal to 1 to n minus 1 f of xi plus f of b. This is the entire expression, okay, consisting of the three terms. Okay, this is the thing. Okay, yes. Now approximating the integral, if for example I am integrating this particular function 0 to 2 x squared dx. Okay, another example if I'll take and use the trapezoidal rule within n equal to 2 intervals, then first of all you have to know a, b and n. Okay, a is 0, b is 2, n is also 2. Okay, within the two intervals that has been given in the problem itself. Then you try to calculate h. H is b minus a divided by n, which is 2 minus 0 divided by 2. Okay. 2 minus 0 divided by 2 is 1. So x values at x0 is 0. At x1 it is 1. And x2 it is 2. Okay. H is the interval. Initial interval is 0. So x plus h plus then the second term will be x plus 2h. Okay. So similarly, I have found out three different x naughts. Okay. 0, 1 and 2. Then evaluating the function x square at all different points 0, 1 and 2. I'll getting 0, 1 and 4. Okay. And plugging into the formula, definite integral 0 to 2 x square dx is h by 2 f of x naught plus 2 times f of x1 plus 2 times plus f of x2. Okay. This is the expression which I have taught you. So that will be 1 by 2 in bracket 0 plus twice into 1 plus 4. So half of 4 plus 2 is 6. So 6 by 2 is 3. Okay. So 1 by 2 into 6 is 3. The actual value which I'll get is definite integral 0 to 2 x squared dx, which will be equal to x cubed by 3. Okay. And then you have to plug in the value 0 to 2 that you will be getting 8 by 3, which is 2.67. So definitely it is the trapezoidal rule is overestimating. Okay. Some error would be there, but you will be able to achieve it till the desired accuracy. Okay. Now you should also know what is the error in the trapezoidal rule, because sometimes it is also asked. Okay. Error in the trapezoidal rule. The error depends on how curvy the function is. Okay. Error formula for the trapezoidal rule is negative of b minus a cube over 12 n square f double dash epsilon. Okay, where epsilon belongs to some some open interval a to b. Okay, more are the intervals, n is smaller. Okay, more values you will get for n, you will have the smaller error. This is the thing. The smoother the function is, the better the f double dash x is. Okay, this particular expression which I have just written is very, very important for the gate examination. Directly in your first part of the examination, where the questions, mathematical questions come. Okay, mathematics and your general aptitude, they are generally mixed. Okay, so within the first part of the gate examination, it is very frequent that you will get 1 mark question or even 2 mark question on directly on this particular formula. Okay, negative of b minus a cube over 12 n square f double dash epsilon. Everything will be given to you in the question itself. A and b directly you can find out using the expression. Okay. For example, if it is definite integral 0 to 2 x squared dx, as in the previous example, you can know directly know this fact that a is 0 here, b is 2 here. Okay, and f dash x you can calculate, which is will be x, f double dash x will be nothing but 1. Okay, so directly you will be able to calculate if n is known to you. N was in previous case it was, I think n was 2. Okay, so directly you can know the error, which is et equal to minus 2 minus 0 whole cube divided by 12 into 2 square. Okay, try to calculate what would be the error in the approximation. Minus 2 minus 0 whole cube. Okay, multiplied by 12 into n square. N is 2 here. Okay, minus 384 multiplied by f double dash x. Okay, f double dash x at any value epsilon. Okay, so f of x is x square. Okay, So f dash x will be 2x. Okay. So f double dash x will be 2 only. Okay. This is the thing here. So directly the error will be multiplied by 2. So similarly, you will be able to calculate the error. Okay. Very important from gate examination point of view. Okay. This is the thing. In summary, what is the purpose? Purpose is numerical integration. What is the formula? H by 2 f of a plus twice summation f of xi plus f of b. Accuracy is very moderate. Error depends on the second derivative f double dash x, and better than left or right rectangles, and it is better than it is simpler than the Simpson's rule also. Okay. This was all about the trapezoidal rule. Okay. Any doubts? Anybody? Anywhere on all of the slides? If any doubt is there in the calculation, then please do tell me. Rest we can move forward. Clear? Not clear? Is it clear? What happened? No answer. Clear? Good. Very good. What about the others? Is it clear to you? Not clear? Then tell me. I'll explain once again. Or where you are having doubt, ask me. What about the others? Why no response? Is it clear to you? Not clear to you? Or is it too tough? Or is it too simple? Clear? Very good. Okay. Okay, fine then. I shall move forward. Okay. Solve this ODE ordinary differential equation using the RK4 or Renz-Kutta method, fourth order method. Okay. The step size has been provided to you. H is 0.2 and the expression has been given to you 5 divided by dx plus xy cube equal to cos x, where y0 is 3. Okay. Calculate the value of y 0.2. Okay. Up to 2 decimal places. Try to calculate. I told you to note down all the expressions k1, k2, k3, k4. Use them as well as the expression of yn will be used here. Okay. Which is y0 plus 1 by 6. Okay. k1 plus 2, k2 plus 2, k3 plus k4 in sum. Try to solve. First of all, reduce it to the standard expression, which is dy by dx equal to f of xy. Okay. Then try to solve it. C. Okay, very good. Very good. Yes, anybody else would like to say anything regarding this question? Only one student has expressed his opinion. C and then B also. Okay, good. Any more opinions? Anybody? Rest, I will tell you what is correct. Okay. It's indeed B. It's not C. It is B. Okay. I'll try to show you the explanation as well as the correct methodology. Okay. First of all, using the RK4 method, you have to reduce the equation to standard term. The expression which you have been given is dy by dx plus 1 by 5 xy cube equal to cos x by 5. Okay. Step size has been provided to you as zero point 0.2. Y0 has been provided to you as 3. So dy by dx is f of xy. This is the standard expression which will be equal to cos x by 5 minus 1 by 5 xy cube. We compute y 0.2 using the RK4 or the Wrench-Kutta method for fourth order. Okay. K1 is h into f of xn comma yn. K2 is h into f of xn plus h by 2 yn plus k1 by 2. K3 is h into f of xn plus h by 2 yn plus k2 by 2. And K4 is h into f of xn plus h yn plus k3. Okay. This is the thing. Then yn plus 1 is yn plus 1 by 6 of k1 plus 2k2 plus 2k3 plus k4. Now we will compute the y 0.2. Okay. See here, step by step explanation has been provided to you. Okay. H is 0.2. First of all, we will calculate k1. K1 is h into f of x naught plus, comma y naught. So f of 0 comma 3 is cos 0 by 5 minus 0.3 cube by 5, which is 1 by 5, that is 0.2. So k1 is h into f of x naught comma y naught, which is zero point 0.2 into 0.2, 0.04. Okay, k1 is calculated. Then you calculate k2. K2 is h into f of x naught plus h by 2 y naught plus k1 by 2. X naught plus h by 2 is your 0 plus 0.1. Okay, because h has been provided to you as 0.2. 0.2 by 2 is 0.1. So 0 plus 0.1 is 0.1. Then y naught plus k1 by 2, this is 3 plus 0.04 divided by 2, 3.02. So f of 0.1 comma 3.02 is cos of 0.1 by 5 minus 0.1 into 3.02 cube by 5. Okay, that you try to calculate, it is coming as minus 0.3115. Okay, 3515. Okay, then k2 is 0.2 multiplied by this particular value that I am getting as minus 0.0703. Then you try to calculate k3. K3 is h into f of x naught plus h by 2 comma y naught plus k2 by 2. Okay, everything has been given to you. X naught plus h by 2 will remain same, which will be 0.1. Y naught plus k2 by 2 is 3 plus 0 minus 0.0703, which you have got in the previous expression. Okay, divided by 2, that would be 2.9648. Okay, so try to calculate this particular value. You will get it 26.063. Then you try to calculate f of 0.1 comma 2.9648. Okay, that you will get as minus 0.0645. Okay, then try to calculate k4. K4 is h into f of x naught plus h y naught plus k3. X naught plus h is 0.2, y naught plus k3 is 3 plus 0. Minus 0.0645, that is 2.9355. Now try to calculate again the values. K4 will come as minus 0.61628. Now try to plug in all the values in the expression y1. Okay, y1 is y naught plus 1 by 6 k1 plus k2 plus 2k2 plus 2k3 plus k4. That whole is in bracket. So you calculate y1, which will be coming around 2.9346. Hence the correct option will be 2.93. That is, I think, your option number B. Okay. Yes. This is the thing. Okay. I know the calculation is a bit lengthy, but if you know the formula and if you are having the time in the examination, which you will be certainly having, because the number of questions is limited. Okay. Please try to solve. Okay. Yes. Any doubts anywhere? Only empirical calculations are there. Nothing new is there. Okay. Only all the empirical calculations are there. Nothing new is there. Okay. I have already taught you. Yes, sir. Can you please explain RK4? Okay. I'll just explain you in brief what is RK4, Rensch-Kutta method for fourth order. Okay. Just a second. This is the final expression which we have got. Okay. Try to explain, try to understand. Okay. I'll try to explain. If any differential equation is of the form dy by dx equal to f of x comma y, the RK4 method is a numerical technique which is used to find the roots of that particular, the solutions of that particular f of x comma y at particular values. Okay. So first of all, we have to reduce that particular value, that particular expression or the differential equation or the ordinary differential equation to the expression dy by dx equal to f of x comma y. Then this particular RK4 method will be used to calculate y at any value x, 0, x1, x2, x3, or f of x1 comma y1. Okay, so this particular RK4 method is used to calculate this particular value. Okay, how you will proceed? H or the step size will be given to you in the question. Okay, here h has been given as 0.2. Now you have to first calculate the four constants, which is k1, k2, k3, and k4. K1 is h into f of xn comma yn. What will be the f of xy? That would be uh, directly given by this particular expression. Okay, you have to reduce the entire ordinary differential equation expression to the standard form. So f of x comma y, that has been given here as cos x by 5 minus 1 by 5 xy cube. First of all, try to calculate this particular k1. All the values have been given to you. Okay, h has been given as 0.2. Okay, and try to see xn or x0 is 0 because y0 is 3. Okay, so x0 is been given as 0, and yn or y1 has been given as 3. Okay, so try to calculate the k1. Similarly, you try to calculate k2, try to calculate k3, try to calculate k4, then you try to calculate y at 0.2. Okay, y at 0.2 you will be directly able to calculate. Okay, which is coming around 2.93, and the detailed calculation is there in the upcoming slides. Okay, this slide I have calculated the value k1, then I have tried to calculate k2, then I have tried to calculate k3. Okay, then similarly k4, then I have tried to calculate y1. Okay, this is the thing. This is an entire Renz-Kutta method for fourth order, and the value which I am getting is 2.93. Is it clear, Kunal, or you are having any doubt anywhere? Then please do ask me. I'll explain you again. Is it clear? Step size will be provided. Yes, step size has been already provided in the question as 0.2. H is 0.2. Okay. Just a numerical method. Only thing which you have to remember are these particular four expressions k1, k2, k3, k4. And then what is the final expression of yn plus 1. Okay. Any more doubts? Or is it clear? Not clear? Step size directly see here. It has been provided in the question. H is 0.2. Always it will be provided. Okay. Okay. I assume it is clear. After the class is over, please take this PDF. Practice these all the 10 examples multiple times. Thereby you will get some confidence. Okay. Yes. Link already I have provided for the all the PDFs as well as the video lectures. Okay, recorded video lectures. Try to solve using bisection method the negative root of x cube minus 4x plus 9. Correct 2-3 decimal places, and the bisection method I already taught you in the previous session. Okay, try to solve. Very good. Yes, very good. We ran a bit slow today. Half an hour is only left, and 4 different problems are there. Okay. So I'll not be able to give you much time. After the class is over, please do look into all the solutions. I have provided the detailed solutions as well as I am explaining you the things. Okay. Take your time and then try to solve these by yourself. Okay. Don't look at the solution. Try to solve it by yourself. Okay. try to look and try to match the answers also. Okay, whether you are getting the same answers as what I have solved. Okay. Yes, it is indeed B minus 2.706. How we will proceed? Let us look at this particular thing. Find the negative root of the expression x cube minus 4x plus 9 equal to 0 using the bisection method. First of all, fx has been provided to you as x cube minus 4x plus 9. Then you have to identify the interval, closed interval a to b, where there exists at least a root, okay, that you have to identify. Already told you, if it is not given in the question, you have to just go with 0, plus 1, plus 2, plus 3, and minus 1, minus 2, minus 3. So when I am calculating f of minus 3, I am getting negative of 6. F of minus 2 is plus 9. So since it is changing the symbol, I already told you that there would be at least one root between the closed interval a to b, because the expressions are different. Okay, the nature of the function is different at f of minus 3 and f of minus 2. So now, since f of minus 3 is less than 0, f of minus 2 is greater than 0, then there at least exists a root between the closed interval minus 3 and minus 2. Applying the bisection method, the formula which is there, which is very simple, it is just calculating the midpoint. Midpoint will be minus 3 plus minus 2 divided by 2. Okay. Evaluating the expression f of x mid and updating the interval based on the sign of f of x mid. Okay. So now try to calculate. Okay. Perform different iterations. Here in summary, I have provided to you. I'll tell you step by step also. Okay. Yeah, this is the same thing. Yeah, I'll proceed forward. First of all, x mid that we will calculate minus 3 plus minus 2 divided by 2, that is minus 2.5. F of minus 2.5 is positive. Okay. F of minus 3 into f of minus 2.5 is negative. So the root would be lying between minus 3 and minus 2.5. So now in iteration 2, I'll calculate again the value of x mid, or the midpoint between a and b. Okay. So minus 3 and minus 2.5, the mid value would be minus 2.75. F of minus 2.75, when you will calculate, it will be coming negative. So yes, there would be again existing a root between minus 3 and minus 2.75, because f of minus 3 is positive. Okay, so there must exist a root between minus 3 and minus 2.75. Okay. Now in iteration 3, a is minus 3, b is minus 2.75. Then you try to calculate x mid, which will be coming as minus 2.875. So f of minus 2.875 is negative, and f of minus 2.875 and f of minus 2.75, they are negative. Hence, the product is negative. Hence, there lies at least one root. Okay, we are narrowing down the region. First of all, we found out the region as minus 2 to minus 3. Now we have narrowed it down to minus 2.875 to minus 2.75. Okay. In iteration 4, A is will be equal to minus 2.875, B will be equal to minus 2.75. Okay. X mid will be minus 2.8125. Okay. Average of both the values. Yes, since f of minus 2.8125 into f of minus 2.75 is less than 0, that there will be at least one root between those two values. Okay. Similarly, we will proceed then at iteration 5. A will be equal to minus 2.8125, B will be equal to minus 2.75. Then when you will calculate, you will directly reach to the value x mid as minus 2.7815125. Okay. So that will be the root till uh, appropriate margin of error. Okay. Within the appropriate margin of error, the root would be approximately lying between minus 2.78125 to minus 2.75. Okay. So you can just see here that it is approximately as minus 2.706. Okay. All the values, they are not coming in the range. This is not coming in the range. This is not coming in the range. Only value which is coming in range is minus 2.706. Okay. Now, when you would be attempting GATE, okay, or any other competitive examination, then there is a shortcut for this particular question also. I'll tell you that also. Okay. If you are lacking in time and you have been provided the options, then nothing, no calculation you have to perform. F of x already has been provided to you as this particular one. Okay. F of x has been provided to you x cube minus 4x plus 9. Just put all the options, and whichever is the option which is closest to 0. Okay. It should be 0.00 or comparatively that you have to see. Whichever is the option which is closest to 0 would be the most appropriate root of that particular function. Okay. So try to see if with all the options, the closest to 0 value you will be only getting in case of minus 2.706. This is the shortcut. This is the shortcut method when it comes to competitive examinations like GATE. Okay, this is the thing. Is it clear? This particular question. Bisection method already I taught you in the previous session. Based on that, I calculated all the roots. Okay, as well as I told you a particular shortcut also. Okay, okay, my dear. Let us move forward because we are running short of time. Okay, just a second. Yes, this is an easy question. Match the following: Newton method, Lagrange method, then trapezoidal method, range Kutta method. Okay, and the other column is integration, root finding, differential equation, interpolation. Okay. Within this lecture only I have taught you all these methods. Okay. One method I just explained you, but I didn't tell you the formula. That is Newton method only. Okay. This question each and every student should try to attempt and they should get it right. Okay. Yes. A, very good. Very nice. Yes, very good. Very nice. What about the other students? A lot of students have joined. Not answering. Why not answering? Why answer? When the function value changes its signs, will those 2 points create the interval? Question number 7. When the function value changes its sign, then will those 2 points create an interval? Yes, definitely you are 100% correct. Because the logic also I explained you. Okay. Suppose the graph of f of x is like this. This is the x-axis. Okay. X-axis. And the graph of the function is like this. And if you will try to calculate f of a and try to calculate f of b, okay, then if since see here f of a is positive and f of b is negative, so f of a into f of b will be negative. So here very easily you can see that there exists at least one root between the closed interval a to b, which is at this particular point, which is c. Okay. So whatever you have written that when the function value changes its sign, it will those 2 points will create an interval. This is 100% correct. Okay. Okay. Very good. Yes, indeed, you all are correct. The correct option is A only. Okay. The Newton-Raphson method is used for root finding. Okay. The Lagrange polynomial is there for interpolation. The trapezoidal rule is for numerical integration, calculating the definite integral value, area under the curve. Okay. The Runge-Kutta method is used for solving the differential equation. We already have solved the differential equation using this particular RK4 method. Okay. This is the thing. The correct option would be A only. Nothing new here. Okay. Nothing much to explain. Let's move forward. You try to calculate the value of this particular expression, definite integral 2.524 ln x dx. Okay. Within the 5 intervals. Okay. Try to calculate what value are you getting. N is 5 here. Okay. N is 5 here. Then you try to calculate h. Then you try to apply the formula. And then you try to calculate what is the value which you are getting. Okay. It is falling in between which two particular values. Okay. Yes. Try to calculate. B, very good. Very nice. B, very good. After the class is over, okay, all of you whomsoever have joined as well as whomsoever you know, all of your friends, share this particular PDF with all of them. Try to solve, okay, each and every expression step by step. At any point of time you are having any correction, miscalculation, okay, you can do. Try to see the step by step procedure, and then only you will be very confident in the examination. Otherwise you will commit mistake and then you will lose marks. Okay, so this is very purely mathematical based questions. Okay, sincerely advised to all of the students, after this session is over, take the PDF and from question number 1 till the end, try to solve each and every question by yourself using a calculator and pen and paper. Okay, the correct option will be B only. All of you have calculated. Very nice. Given integral is 2.5 to 4, definite integral ln x dx within 5 subintervals, that is between 2.5 to 4, there will be 5 equal parts. Calculating the step size h, which is b minus a by n. If the interval or number of subintervals is given, then you always have to calculate the step size using this particular formula, that is b minus a by n. Either you will be provided the number of subintervals or you will be provided directly the value of step size, that is the h. Okay. So h I will calculate here, which is 4 minus 2.5 divided by 5. Okay. 4 minus 2.5 is 1.5. 1.5 divided by 5 is 0.3. Now you try to calculate the value of ln x. x0 is 2.5. Then x1 will be 2.5 plus the step size. Okay. Step size is 0.3. So 0.3 that you add to 2.5, that is 2.8. Similarly, you will get 3.1, then 3.4, then 3.7, then 4. Okay. Try to calculate the value of all the f of x first. Okay. At these particular values. So ln 2.5 I have calculated, ln 2.8 I have calculated, ln 3.1, ln 3.4, ln 3.7 and ln 4. This is natural log 4, that is 1.3863. No need to memorize anything. Either you will be allowed to carry the physical calculator, or if you are not allowed, then you will be provided a virtual calculator that will be entirely mentioned in the admit card itself. Okay. At the end of the session, I'll teach you how to use the virtual calculator. You just have to open this virtual calculator and try to solve, use only that. Okay. That is the thing. F of x has been given and ln x, and we have tried to calculate the value of f of x at different intervals. Okay, this is the thing. Now you try to see applying the trapezoidal rule formula, that is h by 2 f of x naught plus twice of f of x1 plus twice of f of x2 plus twice of f of x3 plus twice of f of x4 plus f of x5. Substitute all the values. I is approximately equal to h by 2.3 divided by 2, and try to put down all the values. Okay. So I is 0.3 divided by 2, and the expressions I have put it and already calculated in the previous slide. Okay. Then what is the value of I which I am getting? I is 1.7533. And a range has been provided to me. So I'll say that 1.74 and 1.76 is the closest match. Okay, hence the correct option would be B only. Okay, this one 1.674 to 1.76, since I am getting the value as 1.7533. Okay, very favorite question for your gate. Okay, this is the most favorite question in the section engineering mathematics and general aptitude. Okay, favorite question of the examiners in the gate examination. Okay, yes, I hope it is clear. Okay, if it is slightly clear or you are getting some mismatch in the values, okay, then try to see yourself in the slides. Okay, next question and the last question for this day. Okay, consider the same recursive C function that takes two arguments. This one, unsigned int function, unsigned int n, unsigned int r. If n greater than 0, return n mod r plus func. N by r, comma r. Okay. Else return 0. What is the return value of the function func when it is called as function 513 comma 2? Okay. This won't be there. Don't get confused. Okay. When I'm calling the function func and providing two different parameters as 513 comma 2, then what value will it return? Okay. This is the last question for the present day. Okay. Try to solve. 2. Very good. Very nice. Cyan. Anybody else will like to tell what would be the correct expression? Anybody else will like to mention which value will be correct? Please go ahead. Good. Very good. Yes, very good. Any more opinions? Somebody supporting 985 also rather than 2. You are welcome. Okay. Any more opinions? Anybody? This is quite easy as compared to previous all the questions. Okay. It is indeed D only. Okay. 2. See the function unsigned int func, unsigned int n, unsigned int r. And then if n is greater than 0, return n mod r plus func n by r over comma r. Okay. Else return 0. The function is recursively computing the sum of the digits of n when written in base r. It repeatedly extracts the last digit of n in base r using n mod r, then calls itself with the quotient n by r. Recursion stops when n is 0. Okay. This means the function is computing the sum of digits of n in base r. When you will see this particular thing, computing it with 513 comma 2. Okay. So 513 mod 2 will be 513 13 divided by 2 is 256. When you will divide it, then you will get remainder as 1. Then 256 point something you will get, so that will be stored. I already have taught you, okay, that whenever an integer is declared, then whatever is the trailing part after the decimals, if the uh, value of the variable is declared as integer, then the trailing part is forgotten, and the only the integral part or the values before the decimal is directly stored in the variable. Okay, so 256.5 will be stored as 256. Then you try to calculate 256 by 2, it will be exactly divisible 128. Then 128 by 2, is 64, remainder is 0. Then 64 by 2 is 32, remainder is 0. 32 by 2 is 16, remainder is 0. Then 16 by 2, remainder is 8, remainder is 0. 8 by 2 is 4, remainder is 0. 4 by 2 is 2, remainder is 0. 2 by 2 is 1, remainder is 0. Then 1 divided by 2, the remainder is 1. Okay, this is only here in computer science. Okay, not in mathematics. 1 divided by 2, okay, that would be 0.5 or something like that. Okay, the value expression, the variable which will be stored, it will be 0. Remainder it will show as 1. So at the end, it is n mod r plus. So it will be directly summing all the values. So 1 there at 513 by 2, and then 1 by 2, the remainder is 1. So 1 plus 1, all the values, when you will sum, then you will get the value as 2. So the correct answer will be 2. Okay. Is this one clear? Very simple. Okay. Simple case of recursion. No any confusion should be there in anybody's mind. Okay, if you are having any confusion, then feel free to see the explanation once again. Okay. Okay, very good, very nice. After the session is over, then please do see the PDF, try to see everything. Okay, anybody is having any doubt, then feel free to ask. Okay, rest, the session is over from my side. Just a small thing is there. I'll just show you the virtual calculator. Okay. Yes. Just a second. Hello, is it audible now? Yes, okay. Yes. I was just explaining you the use of this scientific calculator. Okay. This is the scientific calculator. Okay. This you will be provided if it is an objective type of question. Okay. It would be mentioned. If it is a physical calculator, you all are very well aware how to use that calculator. But if it is a scientific calculator, online scientific calculator, the use of that I am explaining to you. Okay, you have to just understand this particular usage. It would be very helpful for you in the gate examination, because in gate examination I have also appeared in that. This scientific calculator is only provided. Okay, you are not provided any of the physical calculators in the gate examination. Okay, so I am assuming that that would be the case in this particular examination also. Okay, so if you are provided this type of scientific calculator, you can calculate all the values, okay, which are there uh, in the uh, in the problem solving steps. Okay, but only thing which you have to keep in mind that you won't be able to type in the values using the keyboard. Okay, you just have to use the mouse for carrying out different calculations. Okay, for example, the simpler ones I am not telling you. Okay, here all the numeric keypad, inside the numeric keypad. Okay, the expressions are there: 1 2 3 4 5 6 7 8 9, and decimal place is there. You are well aware of that. Okay, then plus minus divide multiply is there, modulus is there, 1 by x is there, then memory is there. Okay, memory functions are there, m plus and minus. Okay, memory clear, then memory recall, memory save, these are the functions. Then in the left hand side you can see all the numerical all the mathematical expressions are there, and as well as the calculation of them is given. Okay, so you try to see, for example, if I try to calculate the expression 2.5 into 2.5, this will be calculated like this. Okay, 2.5 directly multiply star sign, asterisk sign I have used, then 2.5 multiplied by 2.5. That after that I'll press equal to. Okay, press equal to, then I'll get 6.25. Okay, after that I'll press this C. C is clear screen. Okay, and entire values will be gone. Okay, then you try to I'll try to show you some of the calculation which would be somewhat difficult. Okay, for example, calculate when I will be calculating the value e raised to power 2.5. So how I will calculate that? First of all, I have to type in 2.5. Okay, then I'll use this particular button e power x. Okay, so directly when I will do that, I'll get the value of e power 2.5 as 12.1842249. Okay, similarly, another thing was there in present session only, which was lnx. So suppose I have to calculate the value of ln 3.5. Okay, so 3.5, first of all, I will write it down. Then I'll press this particular button, which is just above e power x, which is ln. Okay. So when I'll press the button ln 3, then directly ln 3.5 will be calculated. Okay. It is somewhat different than as compared to your physical calculators. Okay. In case of your physical calculators, first of all, you will press the ln button, then the bracket will emerge. Inside the bracket, you will write down 3.5. Then you will be able to calculate the value of ln 3.5. But this is a virtual calculator, so the procedure here is somewhat different. Okay, that is the only thing. This I wanted to tell you guys. Okay, then press the C button. C will clear all the screen. So this is how you will calculate all the values. Okay, suppose you have to calculate the value of 1057.35. Okay, first of all, I'll write down 57.35 using the mouse only. Okay, after that I'll press this 10 button. Okay, so 10 d is in degrees. Here I have selected the mode as in degrees. That is why 10 d is written. Okay, so in degrees the value of 1057.35 is 1.56. Okay, if I want to convert in radian, just I have to press this radian button. Okay, so that will give me the value in radians. 57.35 I'll write out down again. Then I'll calculate, I'll press the 10 button. Okay, then I am getting 10 r, 10 in radians. Okay, so practice this. Okay, just in Google you have to write it down, Gate scientific calculator, then on the first link itself it will be there. Okay, this all the information which will be mentioned in the admit card itself, whether you will be allowed a physical calculator or you have to use the online calculator. For your benefit, here itself I have provided to you. Okay, I have presented to you that how you can use this scientific calculator, virtual scientific calculator. Okay, here I have demonstrated the functionality. Okay, guys, thank you all for joining the session. Okay, do join the session next week, same time, same link. Okay, yes, the session is over from my side. Okay, thank you all. Okay, if you have any doubt, then feel free to ask. Rest you can leave. Okay, do join the session next week, same time, same link. Okay, thank you all. Thank you, Rishi. Thank you, Shaurya. Okay. Yes, you will be provided at least one rough sheet in the examination. Yes, at least one sheet will be provided. You can use it. Okay. In the examination, you will be provided that. Okay. Okay. Sir, after getting the return value at base case, how can we proceed further for the back process? Question number 10. Yes, I'll explain you that. In case of question number 10, okay, base case which you have been given as 513 comma 2. Okay, this particular value you have been provided. Now you just have to see the return function. It is saying that return n mod r plus call the value at func n by r over r. So first of all, you have to note it down that n is 513 and r is 2. Okay, because the initial value which we are providing during the function call is this only. Okay, this is step number 1. Then what is there? 513 is n, r is constant, which is 2. So 513 mod 2 is 1. And at the next step, it is written plus func n by r comma r. N by r, 513 divided by 2. 513 divided by 2 will be approximately 2, it will be 256.5. So 256.5 will be reduced, okay, to 256. Okay. 0.2, 0.5 and all the remaining values after the decimal, they will be truncated and directly you will get 256. Okay. So that 256 and R is at every step R is 2 only. Okay. So at every step R is 2 only. Okay. This you have to just keep a note of it. Okay. Then you try to see, just a second. Yeah. So 256, okay, divided by 2 in the first step, I have got 256, 513 divided by 2. At the first step, I got 256.5, that will be stored as 256, okay. So n by r in the next case will be 256 and r is constant, which is 2, okay. So this is the thing. So what is the value which I got with n mod r? I got as 1. Okay. And the expression which is now will be called is 256 comma 2. Okay. So when 256 comma 2 will be passed, what is the remainder which I am getting? It is 0. Now 256 by 2, that is 128 will be sent n by r comma r. Okay. So 128 comma 2. So similarly, when you will be dividing, what value will be getting? 64. So remainder is 2 here. Okay. So similarly, when you will proceed, okay, you just have to understand the flow. So 128 divided by 4 was 64. So remainder is 0. So 0 plus that particular function. Okay. n by r, comma r. Okay, n by r is 64 and r is 2 always in this case. So what is the thing which is happening here? The remainders are getting sum and n by r value is directly getting pushed as a parameter inside the function. So at the end, all the remainders when you will add, you will get 1. In the first step, you got 1, and in the last step, you got 1 extra 1. So 1 plus 1 that you finally got 2. Okay, this is the thing. Is it clear? Is it clear? Yes. Okay, very good. It is just the expression n mod r, okay, plus inside the func you are pushing n by r divided by n by r and r is constant which is 2, and n by r whatever the value after the decimal is there that I have truncated. Okay, because n is an integer, r is also an integer, so division of two integers will be an integer only. Okay, this is the thing. See it once again. What is unsigned data type? Yeah, what is unsigned data type? By default, inside the when you are declaring a variable as int a, so it will be 4 bytes reserved. 4 bytes will be reserved, but one would be kept separate as for storing the sign. Unsigned intr means there would be no sign. Okay, sign won't be there even if you will be getting providing the input as minus 256, so it will be stored as 256 only. That is the meaning of unsigned intr. Okay, that is the thing. No byte is stored for storing for the sign of the value variable. That is the meaning. Okay. Okay. Any more doubts? Yeah, it is also stored in 4 bytes only. Yes. But that reserved byte for the sign is removed. That is the only thing. Which answer? Please repeat the answer. Which answer? This unsigned int or anything else? Uncertainty. I'll just explain you. Okay. Give me a few seconds. I'll just explain you. See, what is the thing here regarding the unsigned int? Unsigned int or unsigned integer, it just means that you cannot store any non-negative. Okay, you cannot store any negative integer inside that particular unsigned int expression. Okay, you can only store positive values from 0 to infinity. Okay, you cannot store any negative value inside that unsigned int function. Okay, unsigned int variable type. Okay, this is the only thing. It also has 4 bytes just like the int type, but in int or integer type, you can store negative values also, but in unsigned int, you only can store values which are positive in nature from 0 to infinity. This is the only difference. Okay. Okay. Any more doubts? Anything like to discuss? Okay. 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 Then thank you. Thank you for joining the session. Okay. No doubts are there. Then do join the session next week, same time, same link. Okay. I'll end the session here itself. Okay. Okay. Thank you all.